So good afternoon, everyone, and this is lecture number 3 in distance and displacement. In the previous lecture, we had seen some important concepts about distance and displacement. Yes or no? We had seen what do you mean by distance. We had seen what do you mean by displacement. And in this class, we will go ahead and discuss more about distance and displacement. We had seen that. We had seen what? We had seen that distance and displacement. Distance is a scalar quantity. Do we remember this? Distance is a scalar quantity. It is always positive, and whereas displacement is a vector quantity. Do we all understand this? Yes or no? Please tell me. Do you understand this? Yes or no?
Yes, sir.
Okay. We had also seen that how did we define displacement? We had defined it in many different ways. We had said that displacement is a vector, and I'll just take you back to that class in the past. Displacement is a vector. It has both magnitude and direction. It is a vector joining the initial and the final positions. Everyone remembers them, right? And I told them, and I told you that we should not talk about displacement in terms of distance or shortest distance, because when we are talking about shortest distance, it tells us that it is somehow related to distance, but it is not related to distance. Yes or no? Yes or no, beta? Remember this? Then we had also seen
Yes,
that
sir.
displacement is written as delta r vector, which is final position vector minus initial position vector. And we had seen what a position vector is. A position vector is a vector which tells us the position of a particle. Yes or no?
Yes, sir.
Okay. Now, many a times in your school exam, in your normal exam, they ask you the different comparison between distance and displacement. So what I'll do is I'll show you. I will show you the first comparison, so you can write the heading, and the heading would be comparison between distance and displacement. What is the heading? Comparison between distance and displacement. Have you written the heading, bacha? Comparison between distance and displacement. Everyone has written this heading, yes or no? And then we will discuss some important points here. We'll discuss some important points here. The first point, everyone has heard about this, and we will discuss it. And the point says that the magnitude of displacement is equal to the minimum possible distance. Some people also call it the shortest distance. So the magnitude of displacement is the shortest distance. I told you in the last class, as a last resort, you can understand displacement in terms of magnitude and direction. The magnitude of displacement is equal to the minimum possible distance or the shortest distance. Do we remember this? Yes or no? Please tell me. Magnitude of displacement. And here the most important term is this magnitude. Whenever we are comparing displacement and distance, we cannot compare them. Why we cannot compare them? Because displacement is a vector and distance is a scalar. But we can compare the magnitude of displacement and the distance. The magnitude of displacement is the shortest distance, and therefore you will have this small thing coming into the picture, that distance is always greater than or equal to the magnitude of displacement. Do we understand this? Yes or no?
Yes, sir.
Everything that is in the green column, and I hope everyone is writing this. Yes or no?
Yes, sir.
That is the first thing that you must understand, and you must remember every point that we are doing may come as a question in your exam, and then you should be able to understand them. Whenever we are comparing displacement and distance, we are not comparing displacement and distance. We are comparing the magnitude of displacement and distance. Yes or no? You understand this?
Yes, sir.
Okay, so that is the first point. Everyone has written this first point. Everyone has written this first point.
Yes, sir.
Okay, now in the previous class, we had a discussion about distance is always positive. Yes or no? But displacement can be positive as well as negative. Do we all remember this? Distance traveled by a body is always positive, but displacement can be positive or negative. Now, remember what we have heard in the ninth standard about displacement being positive and negative. It is true, but it is true in what way we have to understand this. Let us first look into the first line. For a moving particle, a particle which is moving, distance can never become negative or zero. Do we understand up till this part? Up till this part, which is in yellow and which I'm going to put in a block. Do we understand this part? For a moving particle, distance can never be negative or zero. Yes or no?
Yes, sir.
Okay. But the next part is the part where we might have a trouble in understanding. But displacement can be zero, it can be positive, or it can be negative. Now, if the particle is moving, can someone tell me when can the displacement be zero? We know this. A particle is moving, it is not at rest.
Sir, which is moving in circular position, sir.
Instead of saying circular beta, can you put it in a more, it may be not in circular motion, bacha. It can be like this. Do you see this? It can be like this, bacha. So you don't have to say circular, because circular means a very specific motion. Can you now rephrase your wording and tell me again, when is the displacement of a particle, of a moving particle, can be zero? When
Sir,
can?
from where it starts and it comes to that position, sir. That time it
Right.
becomes zero, sir.
Right. Zero displacement means the body after motion and come back to its initial position. The most important point here is it has come back to its initial position. And in that case, we can call the displacement as zero. We don't call it zero, beta. It is zero because the initial and the final positions are same. Do we all understand this? Yes or no?
Yes, sir.
Remember, distance can never be zero because distance is always positive. If you are traveling, your distance is always positive. It never becomes negative. And therefore, it can never become zero. Even if you come back to the same position, it can never become zero. But in the case of displacement, if you come back to the initial position, you move in such a way in any path, you can move like this, bacha. You can go from point A to point B in this line, and then you can come back from point A, from B to A in this line, like this. Or you can come back from B to A in this way. Now, if you go from A to B in whatever path, and you come back from B to A in whatever path, distance travel will never be zero, but the displacement will be zero because your initial and final positions are same. Do we understand this?
Yes, sir.
Okay, now the term that confuses a lot of students, and I want to clarify it very correctly. Positive displacement, the pink one, and negative displacement, the blue one. Can anyone tell me what do you mean by positive and negative displacements? And this is the important point that we have to discuss. because it is going to come in many ways, may not be in the form of displacement, but in the form of velocities, in the form of accelerations, in the form of force, any vector that we are talking about. Whenever we talk about vector, this positive and negative term can come. Can you now tell me what do you think by positive, or what do you think about negative displacement? Yes, bacha.
When it moves in positive x-axis, then it is positive.
If it moves in positive x-axis, displacement is positive, and if it moves along negative x-axis, then
Negative or positive y-axis or negative.
okay. So basically, whenever we are talking about positive displacement or negative displacement, we are only talking about one thing and one thing only, and that one thing is the direction of motion. Depending on your direction of motion, you can call displacement as positive or negative. So whenever someone uses the term positive or negative displacement, he is referring to its direction. Remember, positive or negative displacement refers to its direction. You must remember that magnitude of displacement is always positive because it is the magnitude, and magnitude always remains positive. Do we understand this?
Yes, sir.
Whenever we talk about displacement and we call it as positive or negative, we refer to its direction. Now, someone said how it can become positive or how it become negative. Let me give you an example of positive or negative displacement. Remember, positive or negative depends on our reference. If I call this direction, which is the direction of positive x-axis, as positive, then this direction, which is exactly reverse of it, becomes negative. But remember, there is no rule that tells me that the black one could be positive. I can call, I can call, I can call the red one also positive. If I call the red one as positive, then the black one becomes negative. So positive and negative basically depends on which direction we are taking at positive. As a thumb rule, if I talk about thumb rule, when I say thumb rule, what do I mean by a thumb rule? What do I understand by a thumb rule? We take that as our reference, that we will always take it in that way. So that is a thumb rule. As a thumb rule, what we say is, as a thumb rule, what we say is, if a body is moving along positive x-axis, and this is your x-axis and y-axis, a body which is moving along positive x-axis, we call it positive, and a body moving along negative x-axis, we call it as negative. Similarly, if the body is moving along positive y-axis, we call it positive, and if the body is moving along negative y-axis, we call it negative. But we can change it. We are not going to change it because every time if we change positive and negative, every time we will get confused. So we will keep this thumb rule as our rule. Everything going in the positive x-axis, everything going in the positive x-axis for us would be positive. Do we understand this from now on?
Yes, sir.
Then everything going along negative x-axis would automatically become
Negative.
if we are talking about y-axis, everything moving along positive y, or anything, any vector which is directed upwards along positive y, we will take it as positive, and any vector which is directed down below along negative y-axis, we will take as negative. Do we all agree on this sign convention? Yes or no? Please, all of you tell me, say yes.
Yes, sir.
And we are never going to change this, because if we change it every time, then there is a lot of scope that we will get confused. I don't want you to get confused about this. So we are going to always use this convention. This is also known as sign convention. When we see the equations of motion, I will again repeat it, but I hope you have understood this. Yes or no?
Yes, sir.
So if I ask you, Bacha, what do you mean by positive displacement or what do you mean by negative displacement? What would you say? What is positive displacement and what is negative displacement? What do you say? What do you mean by this? Anyone? Who will tell me what is meant by positive displacement and negative displacement? Tell me. I have shut down the screen. Tell me. What do you mean by positive and what do you mean by a negative displacement? Everyone has a mic, right? Tell me. What do you mean by positive displacement and what do you mean by negative displacement? Tell me before going on to the next point. Can you hear me better? Am I audible? Am I audible to everyone?
Yes, sir.
What do you mean by positive and what do you mean by negative displacement? Say.
Direction.
Positive and negative displacement will refer to its direction. Will you remember this? Again, I'm showing you the same screen. Will you remember this? Everyone.
Yes, sir.
Then the next point is, we have seen if a body moves from point A to point B, it can follow any path. Distance depends on the path, but your displacement, my dear friend, does not depend on path. It is always the vector joining the initial position to the final position, and therefore for motion between any 2 points, displacement is single valued. Single valued means it only has one value because there is only one vector that you can draw, but distance depends on actual path and it can have many values. If it goes in the black path, distance is different. If it goes in the blue path, distance is different. If it goes in the green path, distance is different. But in all the cases, displacement will be simply equal to AB vector. AB vector is the vector joining initial position to the final position. That would be the displacement in all the cases, no matter how the particle has gone. Do we understand this?
Yes, sir.
Now, if you have understood this, then there is a very important point that you should note. To find out distance, and I hope everyone is writing it, to find out distance, we must know the actual path. We must know which path the body has followed. If we do not know which path the body has followed, we cannot find out the distance traveled. Do we agree on this? Do we all agree on this?
Yes, sir.
That means I can write it at the second point. To calculate displacement will always be easy, will be easier as compared to calculating the distance, because if we have to calculate the distance, my dear friends, we will have to know the actual path, and that actual path may be very complicated. And therefore, in any question, if they ask you displacement, you should be very happy, because that is a very simple question. You just have to join the initial position with the final position. But if they ask you distance, then you must worry a bit, because then they are talking about the actual path and you must know the actual path. Do we understand this?
Yes, sir.
Okay, so that is what you must remember. Have you written this down?
Yes, sir.
Okay, then I have said that to calculate distance is very simple, but to calculate displacement would be somewhat complicated. To calculate distance would be somewhat complicated, and I'll just show you a diagram as well so that you can remember this and then understand that calculating distance is always difficult as compared to displacement. So here you see a particle going from point A. Do you see this point A, bacha?
Yes, sir.
To point B. It has followed this yellow path. S, I don't call it S, I call it L. L is the length of this path, which is the distance traveled. Yes or no?
Yes, sir.
R vector A is the position vector of point A. R vector B is the position vector of point B. To calculate distance, my dear friends, you will have to calculate the length of the path. But to calculate the displacement, it is very simple. You just calculate final vector. Do you remember that definition? Final vector minus initial position vector. Do we understand this?
Yes, sir.
So which you think is simpler one to calculate? Is it the displacement wala thing or is it the distance wala thing?
Displacement.
Because to find out displacement, you just have to draw a straight line from point A to point B, and that gives you the displacement. Anyone understand this? Yes or no?
Yes, sir.
Can I give you a question now?
Yes, sir.
Okay. And the question is pretty simple. And these are the type of questions that come in the exam.
Sir,
Yes, beta?
can you explain once again, sir?
What, beta? What do you want me to explain once again?
Diagram.
Which diagram? This diagram? What I need to explain here? It
Yes,
has
sir.
moved from A to B, and the path is like this. It is circular sort of thing. To find out the distance, we have to find out the length of this path. But to find out displacement, you find out the final position vector, which is this green vector. You must know the initial position vector, which is the pink position vector. It's like this position vector, the pink one. The green one is like this. Green one is the final vector, final position vector minus initial position vector, my dear friends. Is it clear now?
Yes, sir.
So to calculate displacement is going to be easy, but to find out distance, we might land up in trouble. Do we understand this? Yes or no?
Yes, sir.
Then comes this question. In this question, they have only asked you the displacement, but I'll also ask you what is the distance traveled and what is the displacement. I will give you 1 minute to do this. And the question is pretty simple. A man goes 10 meters north, 20 meters east. What is
Excuse
the
me, sir.
Yes, beta.
Sir, can you show the previous slide?
Okay, you okay. Want to see the previous slide? Okay. It's not slide, it's okay. Yes. Any doubts? Any doubts, please raise them. Not a problem.
No, sir, we are writing that notes.
Okay, okay. Right. I'll give you 2 minutes. Let me know when you are done.
Done, sir.
Yes, beta, are you done?
Yes, sir, completed.
Do you want me to rub the diagram so that you can draw it correctly? Should I rub it? So I've rubbed the entire thing. You can draw it now correctly.
Yes, sir.
Shall I move ahead in life?
Sir, 1 minute.
Okay. Draw it.
Sir, completed.
Okay. Then let's move ahead and I will put forward this question. A man goes 10 meters towards north, 20 meters towards east. What is displacement as well as the distance traveled? Distance traveled is pretty easy, right? In this case, contrary to what I said, how much is the distance traveled? Tell me the first point. How much is the distance traveled?
30 meters.
Distance is 30. It's a number. You can add it like a number. So distance is 30 meters. What about displacement?
10 root 5.
How did you get 10 root 5?
10 meters, sir.
Remember, whenever we're talking about displacement, you must remember displacement is what? What type of quantity?
Vector quantity.
So when you said 10 root 5, what did you tell me? When you said 10 root 5, what did you tell me?
Sir, 10 root 5 northeast.
When you said 10 root 5, what did you tell me? That's my question. What was 10 root 5? When you said 10 root 5, what was that? See, if you can't tell me what did you tell me, that means you did not tell me what you know. You told me what you understood, what you did not understand. And you cannot say what you did not understand because that is of no use. Do we understand this? Yes or no? Are you there listening to me, beta? Can you hear me?
Yes, sir.
When you said 10 root 5, what was 10 root 5? Now, I'll do this question and probably I'll have to wind up the class after this question. Whenever we talk about displacement, it is a vector quantity. There must be two things that you must tell. The first one is magnitude, and the next one is direction. Do we understand this?
Yes, sir.
I again repeat my question. When you said 10 root 5, what did you tell me?
That was another boy, sir.
That was whosoever that was, another student, another person. 10 root 5 is something here in this answer. Yes, 10 root 5 is correct. But what is 10 root 5? What is 10 root 5? 10 root 5 is the magnitude of displacement. So if you do not use the word magnitude, that means we have not understood what you have said. Do we understand this? Do we understand this?
Yes, sir.
Now, how are you supposed to solve this question? So you draw a diagram. Now, let us suppose that the particle, the body is at O. Now, you must remember which is north, south, east, and west. So I will just draw it here. Everyone knows this: north, south, east, and west. Yes or no? Or I have done
Yes, sir.
ulta. I have done ulta. This is west and this is east. Yes or no? So, in first case, how did it move? It moves 10 meter north. So I draw a straight line. It moves 10 meter north. So it goes from O to A, and this entire length is 10 meters. Do we understand this? Yes or no?
Yes, sir.
Then it moves 20 meters towards east. So I draw it a slightly bigger line and I write 20 meters. This is how you must solve a question so that you understand what you are doing. Is everyone there with me? Yes or no? No, yes.
Yes, sir.
Now the first question that you answer is, what is the distance traveled? And the answer is pretty simple for distance traveled, my dear friends. 10 meter plus 20 meters, that would be your distance traveled. Yes or no? No or yes?
Yes, sir.
That is 30 meters and that is your distance traveled. You don't have to say anything else because distance is a scalar quantity and nothing else matters. Now, when someone talks about displacement, now look at this diagram. Remember the definition of displacement and tell me what is the displacement of this particle.
Displacement equals to under root of 10 square plus 20 square, sir.
Under root of 10 square plus 20 square. Okay, let me take you back. 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 This was the definition of...
Sir, distance displacement is OB, sir.
Yes, now you are talking. This was the definition of displacement. And you said 10 square plus 20 square. I don't understand it because that is nowhere coming in the definition. Is it coming anywhere in the definition, bacha? That the displacement is this square plus that square? No, na? So if it is not coming in the definition, that means we'll have to do it correctly and understand it correctly. The only thing that comes in the definition, my dear friend, it is vector joining initial and final positions. Yes or no? No or yes?
Yes,
Do we
sir.
understand this, everyone?
Yes, sir.
Now, I again ask you the same question. What is the displacement, my dear friend, here? What is the displacement here? Tell me, fatafat. Tell me, fatafat. Tell me, fatafat.
Joining initial and final position.
Yes, joining initial and final position with a vector. You can call this vector as OB vector. Your OB vector is your displacement. Do we understand this, my dear friends? That is the answer that
Yes,
I was
sir.
looking for. That is the answer that I was looking for. That is the answer that I was looking for. Now, I can tell you this displacement in many ways. I can tell you the magnitude of this displacement. The magnitude of this displacement will be the length of the line OB. How do I find the length of the line OB? I can do it by Pythagoras theorem. Yes or no?
Yes, sir.
It's a right angle triangle. One is base, one is hypotenuse. So the length of this line will be 10 square plus 20 square. That 10 square plus 20 square, I think is 10 root 5. This 10 root 5, my dear friends, is telling me the length of the line AB, and therefore it tells me what, my dear friend? It tells me the magnitude of displacement. Yes or no? No or yes?
Yes, sir.
Now we have to talk about direction. The simplest way of saying the direction is, sir, it is from O to B, but that will not look good. From O to B, if you want to say the direction in the real sense, you have to talk in terms of an angle. And if you call this angle as theta, remember your O to A is your north. Do you understand this? O to A is your north. Do you understand this?
Yes, sir.
Now you can tell me the value of this tan theta. Yes or no? How much
Yes,
will be
sir.
the value of this tan theta? Tell me, fatafat. Tan theta is perpendicular divided by,
Opposite height adjacent, sir.
so 20 divided by 10. Yes or no?
Yes, sir.
Tan theta is 2. So now to tell me the direction, you can say, sir, the displacement makes an angle. It makes an angle which is equal to, if I find out angle, it will be tan inverse 2. Yes or no?
Yes,
Inverse
sir.
angle. It makes an angle tan inverse 2 with which axis? With the north direction or the north axis. Do we understand this? Yes or no?
Yes, sir.
That is the way of saying this in one way. I have told you the magnitude and I have told you the direction. Everyone understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Pakka, sir? Pakka? Pakka. That is one way of saying this. You can say its magnitude, or you can say with magnitude, you can say its direction, or this is one way of saying this. So whatever comes in this dabba, it is one way of telling me about the displacement. Everyone understands this dabba?
Yes,
Remember,
sir.
the answer was very simple. Someone gave me the answer straight away, 10 root 5, but for me it is important for you to understand what is the meaning of that answer. Do we understand this now?
Yes, sir.
Everyone tell me yes. This is the first way of saying this. Everyone has noted this down? Everyone has noted this down?
Yes, sir.
Now there is a second way of saying the same thing. Remember, we are talking about OB vector. Yes or no? OB vector is a displacement vector. Yes or no?
Yes, sir.
Now you can always make one x-axis. So this is my x-axis. Do you see my x-axis? My positive x-axis? Yes or no?
Yes, sir.
This green is my positive x-axis. Yes or no? This blue. This blue is my positive y-axis. Do we understand this?
Yes, sir.
Okay, sir. Then you must understand that I have a unit vector. which I call I along x-axis, and I have a unit vector j along y-axis. Yes or no?
Yes, sir.
I can write this OB in the form of vector. When I say in the form of vector, I can write it in terms of I and j. Last chance. Can anyone tell me OB vector in terms of I and j? In terms of I and j, my dear friend. In terms of I and j, what is OB vector? In terms of I and j, x-axis, y-axis.
10j cap.
Well done, my dear friends. 20 I cap plus 10 j cap. This is the most wonderful way of writing the displacement, because now we understand that this gentleman is a vector quantity. Yes or no?
Yes, sir.
Now I can find the magnitude also, but bacha, very easily. OB vector ka magnitude is simply OB ka length, that will be equal to x square plus y square. Yes or no? Ka root.
Yes, sir.
So it will be 20 square plus 10 square ka root. You can also find the angle with the x-axis or with the y-axis. Here we have calculated the angle from the y-axis. Do we understand this?
Yes, sir.
This is all about distance and displacement in one example. In the next class, I will go ahead with other examples on distance and displacement. I'll have to leave your class 5 minutes early today. So we will continue with this. Do you have the sheet for this, bacha? Problems on distance and displacement. Do you have the sheet in your module? Do you have it? Yes or no?
Yes, sir.
Okay, so try questions on distance and displacement. I will take more questions in the next class, and we will start with speed, velocity, and other things also. I'll wind up this class here because my computer might shut down at any time. If you have any doubts, please ask me. Else, from my side, this class stands over. So if you have any doubt, please ask me.